let's take a look at 6.1 real quickly. So we are talking about movement in a plane. So if y'all will read through this first page for just a minute, I'll go back and highlight some important parts, but I'm not going to read to you. So read through the first page for me.
Miss Bell, you come back. Go ahead. Where are the leaders in the Carlos College of returning the bucket?
Yeah, no pressure basic. You have a problem with them, so yeah. You still look like a freshman. How do you say that? Left ball.
About parametrics here today. And so what happens with parametrics is that x and y, you may want to jot this down somewhere, x and y are dependent on some other variable, and I'm going to call it t. So sometimes they're going to call it f, but I like to call it t because most often they're dependent on an amount of time, and so I like to call it t. Sometimes, like on this first one we're going to work, it's on distance, so that'll be a little bit different, but again, a lot of times the parameter that we're talking about is t. Okay, so to write that, we're going to have kind of two equations that we work with, like x at t and y at t, like that. Okay, so that's kind of what our equations are going to look like. So normally we have like y of x or f of x. Now we're going to have two things, and one will be like x in that given amount of time t, or y in that given amount of time t. So again, often we're talking about time. So what we want to think about here is that, I'm going to highlight this part right here, the coordinates that we're working with on this first example here are dependent on where S has traveled along a path. And so they're going to be dependent on a distance. It's going to be really important as we work here. Okay, I am still working with the point 0, 0 being our starting point down here. Okay, and then what we're going to measure along here, again, is a distance. So this is like the distance that we're walking right here. And that's what our x and our y are going to be dependent on. It is a curved line, but we're going to approximate this thing using the hypotenuse of a triangle, really of a right triangle. Okay, so even though our line is curved, we can kind of approximate some distances here based on the hypotenuse of a right triangle. Okay, so for example, if I want to know the distance that I've traveled at an x value of 2, I could say that this is 2, and this is 2, and then I could find this hypotenuse right here, and it would be a pretty good approximation of what that distance is. Okay, so just to give you a little example, we're not going to find that right now, but that's kind of what we're going to look at, is the hypotenuse of these triangles. It gives us a good approximation. Okay. Each little unit here is going to be a value of 1, so that can be kind of important. All right. Very good. Okay, so flip over to the back side. We're going to keep kind of working with that same situation where we're talking about things in terms of distance. Okay, so this is the graph we're working with now. Again, S is in distance, and number 1 asks me to describe the behavior of x of S between the points 0 and A and B, and then B and C. Okay, so what I want to look at first is the x values. Okay, so as S is moving, I want to look at what's happening between the x values of 0 and A. I'm sorry, 0 and A. Okay, so between 0 and A, I'm going to say that x is increasing. Okay, so again, I'm just looking at x, so I'm looking right here. Okay, so here's 0, here's A. My x increased from 0, back from 0 to 1. Okay, so from 0 to A, my x value increased from 0 to 1. Okay, so this is going to be 1 right here. Okay, let's look at from A to B. so between A and B on my line here, what happens to my x values down here? Okay, but look at your x values. Good, okay, so x is increasing, good. Okay, this time from what to what? 1 to 2, good. Okay, so we're looking at A, B, and C on that line, but we're looking just right now at our x values. Okay, and then finally, from B to C, all right, what's happening with x between B and C? Yeah, still increasing. Okay, and what are my x values increasing from what to what? 2 to 3. Good. Okay, so I'm only looking at the x values. Okay, y'all give number 2 a try. So on number 2, you're looking at what's happening on your y values. Okay, number 2, looking at what's happening on your y values. Okay, so let's start from 0 to A. All right, this time I'm looking at my y values, so I'm looking at my y-axis over here. So from 0 to A, are my y values increasing, decreasing, or constant? Increasing, good, from? Good. Increasing from 0 to 1. Okay, now we're going to change things up a bit. What's happening to my y values from A to B? They're the same, good. So let's use that word constant. So let's say y is constant. Okay. You could say from 1 to 1 if you wanted to, but constant means that it's not changing, so you're good. Okay. All right, and then finally B to C. Is y increasing, decreasing, or constant? Good. Y is increasing from 1, 2, 3. Good. Okay, they told us that we do not need to be able to do number 3. So let's skip over number 3. All right, and we're going to jump down here to number 4. Okay, so on number 4, I want to start finding some values here. So let's start with x at 2. Okay, x at 2. All right, remember that 2 is my s value. Okay, so what I'm trying to find is what is x when s is 2. Okay, so let's look at some values for s real quick before we move on. All right, so if I'm talking about a distance, I'm talking about how far I went along this line right here. Okay, so this is where I'm going to use that right triangle that I was talking about. Let me highlight my right triangle here. So here, and here, and here. Okay, so what are the lengths of my sides of that right triangle? 1, good. Okay, so this is going to be 1, and this is 1. So I'm going to say that 1 squared plus 1 squared is equal to s squared. Right, so 1 squared plus 1 squared gives me 2. So my s value right there is going to be the square root of 2. Which the square root of 2 is like approximately 1.4142, right? Yeah, I was like, I didn't do that right. Yeah, 1.41. There we go. Good. Okay, so that's kind of where we're looking at there. All right, let's go ahead and find our distance here. All right, so from here to here, from A to B, my distance is just 1. Okay, so I've moved over 1 unit. Okay, so this is a distance here of the square root of 2. And then this one right here is a distance of 1. Okay, let's go find the distance from B to C. Let me get a different color. Okay, so from B to C, I'm going to use this triangle here. Okay, where this side is 1. What's this side right here going to be? 2. Good. So I'm going to have 1 squared plus 2 squared equals s squared. So 5 equals s squared, so s is going to be the square root of 5. Find that decimal approximation, 2.36. 2.236. Having trouble with my tenths places today. Keep leaving those out. Okay, so we know the distances now. Okay, so what I want to find, this is kind of tricky, so stay with me here. On number 4, part 1, I want to find where my distance is 2. Where my distance is 2. Okay, so I know my distance here is 1.4. Okay, so how much more do I need to get to 2? 0.6, good. Okay, I know that this is 1 right here, so I'm going to move over here 0.6 more, and that's going to give me that x of 2 is at 1.6. Okay, do you want me to say that one more time? That's kind of hard. This is kind of a weird concept. Okay, so let me say it one more time. So I know the distance from here to here is 1.4. I'm trying to get to a distance of 2. So I'm going to move over another 0.6 and be right in here with an x value of 1.6. So I'm trying to find my x value when my distance is 2. Does that kind of make sense? Okay, let's try another. Okay, this time we want to know on number 2, part 2 here, what value of s yields the coordinate point 1.51. Okay, so let's go find that first. Let me get a different color here. All right, so 1.51, so this is my x and my y. All right, so 1.51 is going to be this point right here. Okay, so I want to know what my distance is at this point right here. Okay, so I know I've gone 1.4 here. How much further am I going to go right here? 0.5, good. So 1.4 plus 0.5 gives me a distance of what? Yeah, 1.9, good-ish, yeah. Okay. So technically that square root of 2 would keep going on, but we don't need to include all of that. Just 1.9-ish is fine. Okay. All right, last little piece here. It wants to know what is y when x is 2.5. Okay, so I'm going to go to 2.5 for my x, and I'm going to find y. Okay, so this time I don't really have to worry about s at all. Okay, I'm just trying to find the y part of my point. Okay, so let's go to my x-axis, and I'm going to go over to 2.5 right here. And I'm going to go up, and my graph is right here. So what y value do I have for this point right here? 2. That's right. Good. Okay, we're going to practice some more of these. So y of s, oops. Y of s is 2. Okay, so I want to get a little more practice with this, but let's do it on your homework. So that's the end of that exploration, because if we did in graph 3, we don't have to test our graph on number 5. All right, so turn over in your homework part to 6.1.1. It looks like this. Whoop, it's that very first page of your homework. Okay, there's 3 of these. I'm going to work number 2 with you, and I think you have all the answers right there. Did they give you? I think they gave you all the answers. We are not going to do the challenge parts. It says that the challenge parts are optional, so I'm going to take those off. So you can go ahead and just cross through. All 3 of them have a challenge, and you can cross through all 3 of those. So just take the challenge off. If you really want to, you have the answers there. You can try it, but you don't have to. Okay, so again, I'm going to start by finding my S values, which are my distances. Okay, so I can see X and Y pretty well. I'm going to start by finding my S values. Okay, so my first S value, I'm going to work number 2 with you. So my first S value right here would be the distance from 0 to A. All right, so how far have I traveled from 0 to A? 1. Good. Okay, I'm going to write my S values just kind of right above. Okay, my next set here is going to be from A to B. Okay, so from A to B, I'm going to need to find that triangle, hypotenuse. Okay, so this side is 1, and this side is 1, 2, 3. So that's going to give me 10 is equal to S squared. So S is going to be the square root of 10. Okay, so the distance from A to B is going to be the square root of 10. Okay, then I'm going to split up B and C and say that this is a distance of 1 and this is a distance of 1. So my total distance from B to C would be 2. But you'll see in just a minute, I'm going to need that in some little pieces. Okay, so just kind of hold on to that idea for a minute. Let me go ahead and put my 1 and my 3 down here as well. Okay, so go ahead and finish labeling your axis there. They didn't label 1 and 3 for you, but they're right there. Okay, so the first question here is what value of S yields the coordinate point 2, 3? All right, so 2, 3 is an X and a Y. So I'm going to go to the point 2, 3, and I'm right up here at B. Okay, so by asking me about the point 2, 3, they're asking me about point B. Okay, so 2, 3 is this point right here. Okay, so I want to know what my distance is, and you can just go ahead and leave these as a square root. So my distance from 0 to B would be 1 plus the square root of 10. Do you see that? So my answer is going to be 1 plus the square root of 10. These are kind of weird. It's almost like you're starting to work in like an XYZ plane because you've got this third kind of component coming in. So they're kind of strange. Okay, give B a try. See if you can find the distance to the point 4, 3, which is point C. Okay, so see if you can find the distance from 0 to C. Okay, so from 0 to C, I've got this distance of 1 plus this distance of the square root of 10 plus, then I've got this distance of 1 and 1, which is 2. So I'm going to say that the total distance is 3 plus the square root of 10. Okay, so I want 1 the square root of 10, and then 2, 3. Okay, part C is asking me to find x. So find x when s is equal to 1. Okay, so part of these questions is trying to figure out what they're asking you. Okay, so this one's asking me to find my x value when my distance is 1. Okay, so look at your x-axis, find your distance of 1. Okay, what's my x value going to be? 1, that's right, good. Here's my distance of 1 right here, and I'm at an x value of 1. So x at 1 is equal to 1. Okay, D is asking me to find y when s is equal to 1 plus the square root of 10. Okay, so s is my distance. So I'm going to go 1 plus the square root of 10, and I want to find my y value. What's my y value right there? 3, that's right, good. Good. Okay, you try E and F. Right together, try E and F, see if you can find those.
S is distance from so y equals, yeah, it's s at 1 plus square root of 10, whatever the y is for 1 plus the square root of 10. So you go 1 over it, and then try 1 over it. Yeah.
And then tell what your y value is. Okay, so let's do this one. So in this one I'm looking for x. So I want to go 2 plus the square root of 10. So I'm going to go 1 plus the square root of 10 plus 1 more, because I'm looking at 2. And I want to tell what my x value is of this point right here. So my x value would be 3. Okay, and then y, this one I'm looking for my y value when I've gone 3 plus the square root of 10. So I'm going to go 1, square root of 10, 2, 3, which puts me over here at c, which my y value is 3. Okay, any questions on that one? So just pay really close attention to whether they're asking you about what is s or what is your x or y values. Just be very careful with that. I think that's the hardest part. Okay? Very good. Okay, so I'll give you some time. You can finish up 1 and 3. Again, you don't need to do the challenge part of it, just 1 and 3, A through F. And let me know if you have any questions.